Hello, my dear students. Welcome you all to Sri Jayendra Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking the organic chemistry. My dear students, we have started today chemistry in everyday life. Under this chapter, we will be studying the applications of chemistry, the fields where the chemicals are required. There are different types of contributions given by these chemicals, like in respect of drugs, in respect of food preservatives, in respect of cleansing agents like soaps and detergents. So, in this chapter, we will be studying the medicinal chemistry, the chemistry involved in food industries, and different types of synthetic detergents. Okay, fertilizers. Now, starting with drugs. Drugs, they are the chemical substances of low molecular weight. They are the substances, chemical substances of low molecular weight used for different purpose, like diagnosis, prevention, relief, or cure of a disease. So drugs, these are the chemical substances of low molecular masses which are used to cure disease or which help us to get relief from the suffering of pain and other symptoms. The word drug is derived from French word drogue, which means a herb. Okay, as they have low molecular masses, of around 100 to 500 units, when these chemical substances or drugs are used for therapeutic purposes, it is known as chemotherapy. Known as chemotherapy. Okay, so when these chemical substances or drugs they are used for therapeutic effects like diagnosis, prevention, it is known as what? Chemotherapy. Okay, understood? Drugs imposing harmful effect on body, such as side effects or toxicity, are known as poisons. Okay, they are known as what? Poisons. Now, drug administration means taking of drug or the way of taking of drug. It can be oral, it can be intravenous directly into blood, it can be intramuscular directly into the muscles, it can be just beneath the skin, subcutaneous, beneath skin. Okay, all these forms, intravenous, intramuscular, they are injectable forms. And oral form is ingestible form. Okay. Now, what do you mean by a pharmacological effect of drug? Effect of drug. The pharmacological effect is a reflection of a drug which is basically useful for doctors or the prescribers who is going to prescribe. It is useful for doctors because it provides them the whole range of drugs available for the treatment of a particular disease, for a treatment of a particular disease, like analgesics. They have pain killing effect, pain killing effect. Antiseptics, it maintains the sterile environment. By killing microorganisms. Okay. So the pharmacological effect, basically every drug is having its own pharmacology, its chemical formula, which is used for the doctors to basically look that whether that drug is going to help a particular problem or not. Okay. Now, Moving next to that, on what basis drug is designed, what are the factors which basically helps to design a drug? Okay, the first is the targets, drug targets, and the second is the metabolism of drug. Okay, drug targets are molecular targets. These are molecules like carbohydrates, lipids, okay, proteins. Molecular targets like carbohydrates, lipids, proteins, and nucleic acids. All these are biomolecules. Okay, these are known as what, target molecules or drug targets. So all these molecular targets like carbohydrates, lipids, proteins, and nucleic acids, they are the drug targets. Okay, drugs having some common structural features may have same mechanism of action on targets. On targets. So the biomolecules which are having same structural features, okay, they basically provide a way, they basically provide a path for more than one type of drug to act upon them and to pursue the chemical function. Okay, every drug is basically having a receptor. Okay, when we can say, sorry, every target is having a receptor, receptors or active site. It's a three-dimensional configurational plane, or we can say a space where drug is attached. So this three-dimensional configurational plane or space, it can be a functional group. It can be any, what we can say, active site or a receptor or a protein channel, okay, where drug is going to attach. Okay, usually receptors are proteinaceous in nature. Proteinaceous in nature, mean made up of protein. Understood? Now, the second point is drug metabolism. Whenever a particular drug is designed, there are some common points which are kept in mind, that every drug is associated with its biotransformation in its conversion into compounds which can be assimilated or absorbed by body tissues or the target tissues. So each drug is basically associated with the process which is known as what? Biotransformation, in which the drug, simple saying, the complex nature of the drug is converted into a simple nature or simple compound which can be easily assimilated or absorbed by the target tissues. Okay. Now, drug when taken orally takes more time to get biotransformed as it is converted or tried to be converted by different body tissues. But ultimate biotransformation takes place in liver. Liver is the site where biotransformation takes place. So it's always better to take a drug to take a drug whose biotransformation is easy and of short duration. Then the amount of drug which goes waste should be minimal. Okay, because after biotransformation there is, around more than 30-35% amount of drug which goes as a waste. Okay, so if more waste is generated by body because of that drug, more effect or more impact on the kidneys will be there. Okay, the simple saying is, we have to take a drug, we have to make a drug, okay, which can be easily transformed. Okay, less impact, less ill effects, less side effects on the tissues involved other than target tissues. Target tissues. Okay. Now, every drug is having a lead compound is having a lead compound which serve as starting point for its therapeutic effect. For its therapeutic effect. Mean the good effects, the biological effects of the drug, okay, is because of the lead compound. If there is more concentration of lead compound, then there will be more of therapeutic effect. Okay, so it is to be remember kept in mind that okay, whenever a drug is designed, then the lead compound should not be forgotten. Okay, now classification of drugs. Okay, first is antacids. These chemicals are usually weak bases. Bases which are used to neutralize excess of HCl produced in gastric juice. Okay. Examples: sodium bicarbonate, milk of magnesia, milk of magnesia. Okay. Aluminium hydroxide. Most common is sodium bicarbonate. Most excessively used. Okay. And can make stomach alkaline. After increasing the pH of the gastric juice, a feedback mechanism operates which trigger more amount of secretion of acid and trigger the formation of even more acid. If sodium bicarbonate is used in very excessive amount, it can trigger the formation of more amount of acid. Okay, that is why MgOH whole twice milk of magnesia is a very good alternative. Very good alternative. They are insoluble and do not increase the pH above the optimum level. Okay, so milk of magnesia is a very good alternative, you see. Okay, because if someone is taking more amount of sodium bicarbonate, so it will slowly and slowly make the stomach more alkaline, okay, by increasing the pH. And as the pH increases, what will happen, it will trigger the formation of more amount of acid by feedback mechanism. That is why milk of magnesia, aluminum hydroxide is a very good alternative, as they are insoluble in water, especially mgOH hold wise, and they do not increase the pH above the optimum level. Okay, so these are antacids. Now come after the antacids, drugs are basically classified on the different criterias, okay, like basis of classification of drugs. We will be doing, we will be considering, we will be talking about each and every category of drug. Okay, first we will do the basis of classification of drug. Okay, first is on the basis of pharmacological effect. Okay, under this classification, the drugs, they are classified on the basis of the chemical formula, the pharmacological effect on the drug, okay, target they are having. Okay, so on the basis of pharmacological effect, like analgesics, their pharmacological effect is pain relieving, antipyretics, they help in lowering the body temperature, body temperature, antiseptics, they can be bactericidal, they can be bacteriostatic, kill or arrest the growth of microbes, microorganisms. Okay, antidepressants, they help in changing the mood, effect on the central nervous system, central nervous system. Okay, now the second is the pharmacological classification is very important for the doctors. Okay, because as the doctors, they need a proper treatment line for treating any particular disease, okay, having the known background of that drug which they are giving to a patient. The second classification is on the basis of action on a particular biochemical pathway, on a particular biochemical process. In this type of classification, the drug action based on the action of drug on a particular biochemical process. Okay, like all antihistaminics, all these antihistamine drugs, they act against the H1 and H2 receptors, inhibit the action of histamine, which is a potent bronchoconstrictor and vasodilator. Okay, so all antihistaminic drugs, they inhibit the action of histamine, okay, which is the prime source of causing the allergic response of the body. So jitni bhi mean all the histamine antihistaminic drugs, they inhibit the action of histamine, okay, and controls the allergic process and controls the allergic process. Okay, the histamine is basically a, we can say, a vasoactive compound which affects the blood vessels as well as the bronchioles. So excessive release of histamines basically constricts the bronchioles and dilates the blood vessels. As the cutaneous blood vessels dilate, the blood pressure, especially in the region of skin here, it slows down. And because of bronchoconstriction, the airway passage get blocked. Because of this airway passage get blocked, the person is unable to breathe, and the condition starts with, upcoming of the allergic attack. Okay. Third is on the basis of chemical structure. The drugs having similar chemical structures have similar pharmacological effect. Pharmacological effect. Okay. Example, alcohols, they are mild to moderate hypnotic agents, induces sleep. They are mild to moderate analgesics, pain relievers, and that too, they also have antimicrobial action in high concentrations. 70% of isopropyl alcohol is used as a antimicrobial agent. Okay. Then sulfonamides, they have common structure to many antibacterial drugs or antibiotics. Next comes the on the basis of molecular targets. If the drug is acting upon different targets, okay, their mechanism of action will also be different. So drugs, they actually interact with these biomolecules as I have already explained, okay, like proteins, carbohydrates, lipids, and nucleic acids. Okay. So the ones which are having same structural features have the same mechanism of action on a specific drug target molecule. Drugs acting upon same enzymes and receptors, okay, when they have common drug targets, may produce same effect or having same mechanism of action. Okay, now we are going to study the interaction of drugs with the targets, how these drugs they interact with the targets. Okay, the drugs interact with these macromolecules such as carbohydrates, proteins, and nucleic acids. Okay, so they may have receptor sites, the proteins which perform the role of, so the drugs they interact with the targets in different ways. Okay, like there's a proposed mechanism for drug target interaction. Okay, first of all, we'll see that what are enzymes. Enzymes, they are the proteinaceous molecule which are biocatalyst. They are biocatalyst. Catalyst, you know what are catalyst. Okay, so they are biological catalyst. Then second thing is receptors. Receptors are the proteins which are very vital for communication. Okay, communication of the effect of therapeutic agent or drug. Then comes carrier proteins. The proteins which carry the polar molecules across the cell, polar molecules across the cell membrane, across the cell membrane. So proteins which help to carry different types of nutrients, okay, or the other substances across the cell membrane, they are known as what? Carrier proteins. Known as what? Carrier proteins. Okay. Now, enzymes, they perform two main functions. First, to provide a space for the substrate, to hold the substrate for a chemical reaction. Okay. Every substrate is basically held by enzyme in an active site. They have an active site. Active site is nothing but a three-dimensional arrangement of groups. This three-dimensional arrangement of groups provide a space for the attachment of a substrate. Okay, so the substrate is held in an active site. They have an active site for holding substrate. The substrate. Okay. Substrates, they are bound to amino acid groups of the proteins on the active site. Usually substrates, they bound to amino acid residues of the proteins. With the help of different forces, it can be van der Waals force, it can be hydrogen bonding, it can be dipole-dipole interaction. Okay, this is the active site. This is enzyme. This is the active site. This is the substrate. Okay, the substrate attaches to the active site to form enzyme substrate complex. So basically, what I can make you sure about it, that drugs and substrate, they compete for a particular active site of an enzyme. So basically what happens, okay, usually each active site is for substrate of same or compatible structure. Okay, so each active site is basically having a space for a substrate. A substrate should be compatible to that active site. Okay, so usually when drug is given to a patient, then the drugs, they act upon these active sites for their attachment. For their attachment. Was inside biological system, the process is only controlled by enzyme. Okay, so the first function of enzyme is to hold the substrate. The second function of enzyme is to provide a functional group which will attack the substrate and carry out the chemical reaction. Okay, the second function of enzyme is to provide functional group which will attack the substrate and carry out the chemical reaction. Okay, drugs, they help to increase or decrease the enzyme catalyzed reactions. Okay, the role of enzyme catalyzed reaction. Inhibition of enzymes is a common role of drug action. Okay, so the drugs, they basically inhibit the enzyme by two different processes. First is the competitive inhibition. Okay, in competitive inhibition, the substrate and the inhibitor, here inhibitor is a drug. Okay, it cannot bind to the enzyme at the same time. Okay, in this case, if the inhibitor is having more affinity for the active site, okay, where the substrate usually attaches, the substrate and inhibitor, they compete to each other. The substrate and inhibitor means the drug compete for the active site. The one which is more favorable structurally, three-dimensionally, their structural configuration is similar. They are attaching, they are forming a good bonds with the active site they will attach to. Okay. So this type of interaction is known as what? Competitive inhibition, in which the substrate and the drug they interact, they compete with each other for the common active site. I'll show you with the help of diagram. Okay, this is enzyme. Now we are having, suppose this is substrate, this is inhibitor or drug. Here you can see the inhibitor is more compatibly fit for this active site. Okay, the structure of both of them will be same, but there may be some minute differences which can lead to a final reaction to happen. Okay, so here the inhibitor will attach. So as the inhibitor will attach, the drug blocks the active site of the enzyme, and enzyme cannot catalyze the conversion of that substrate into product. So this case, the substrate cannot be converted into product because there is a blockage over the enzyme active site. So this is known as what? The competitive inhibition. In the second, we are having a non-competitive inhibition. Non-competitive inhibition in which there is a site other than the active site. Non-competitive inhibition in which we have a site other than the active site, like okay, here we are having a site known as what? Allosteric site. This is enzyme. This is allosteric site. And this is active site. Okay. In this category, the drugs they cannot bind to the active site because they have a different site to bind upon. Okay. The drugs they cannot bind to the active site. Okay. So the drug will bind to the allosteric site, and there can be many possible reasons for that. Drug can bind to allosteric site. Allosteric. The drug can bind here. It can come here. And as the drug binds to the allosteric site, okay, binding of drug to allosteric site changes the quaternary structure of protein, that is enzyme, and as the enzyme protein changes with the quaternary structure, the active site becomes non-acceptable for the substrate. Okay, it is like that okay, I cannot bind to the active site, but I can destroy the structure of the active site so that no substrate can attach to the active site. That is the main, vision of non-competitive inhibition. Okay. So this is the competitive inhibition and the non-competitive inhibition. Now, enzymes, they can act as a drug targets. There are some receptors as well. They can also act as drug targets. To receptors as drug targets. Okay. Every receptor, it basically receives a chemical messenger. It receives a chemical message. Okay. And if the shape of the receptor gets changed, okay, then it may lead to some abnormal function, or it may lead to some different function with increase or decrease rate. Okay, so it is basically what happened that, for example, if I'll make a plasma membrane. This is plasma membrane and this is a receptor. This is a receptor. Okay, plasma membrane is made up of proteins and lipids. Okay, these are phospholipid tails. This is interior of cell. This is exterior of cell. Okay, this is the binding site and this is chemical messenger. Chemical messenger. So receptors, they receive the chemical messenger. Okay, so there are many theories for the formation of enzyme substrate, like lock and key mechanism. Okay, which we have just discussed about the competitive and non-competitive inhibition, that there is a lock and there is a key. The lock is placed in the enzyme and the key is the substrate itself. So if the right key is placed on the right substrate, then the reaction will happen. The other theory is induced fit theory. This is the induced fit, mean a snugly fit. It is not like that it will make a bond. So it will be remembered that whenever a drug is attached to the receptor or a drug is attached to the enzyme, the bond should be snugly fit. Snugly fit means it is not too strong, not too loose. Okay. Now whenever the this is the change in the outer structure of receptor after receiving the message. Okay. The binding site will change. Now the chemical messenger will not able be to attached. Okay, so receptors, they also act as a drug targets. Okay, so these receptors, they are basically placed in between the neurons or in between the neurons and muscles. They act as a chemical messengers. They help to provide the chemical message in the form of ions or anything. So after the drug is attached, when drug is attached, the shape of receptor changes and it will not allow the substrate to enter to enter inside cell. Understood? So these are the ways that how drugs they act upon, okay, whether it is the inhibition and the second is the receptors as drug targets. So the receptors they itself act as a drug targets, okay, and they perform the functions. Now we are going to talk about chemicals in medicines. Antacids we have already discussed. Okay. So chemicals in medicines and healthcare. Different categories of medicines we will discuss. There are some common terms. First is agonist. Agonist, a drug which basically stimulates or activates the receptor. Drug which stimulates or activates the receptor. Okay. To initiate a physiological response. Function. Any biochemical process, any metabolic reaction. Response. Function of, okay. It is known as what? Agonist. For example, acetylcholine is an agonist to cholinergic receptors. Cholinergic receptors. Okay. When they mimic the natural receptors, okay, to switch on the cholinergic receptors. The second is antagonistic. Antagonistic. The drugs which occupy the receptor sites, the drugs occupy the receptor sites without producing any physiological response. Without producing any response. They are known as what? Antagonistic. Okay? They inhibit the natural function. They inhibit the natural function. Okay? Now, in example of antagonistic drugs, we can write that there are two types of adrenergic receptors for stimulating the sympathetic nervous system, alpha and beta. Okay, so but both alpha and beta adrenergic receptors they have different binding sites. Okay, so that is why the alpha is, for example, heart has more than beta receptors. Okay, more of beta receptors than alpha receptors. So if more alpha receptors attached to the heart, okay, then the process will be reversed. Okay, so antagonistic means which will stops the agonist to act upon. Okay, now classification of drugs we have already completed. Okay, now we are going to discuss about the drugs, different types of drugs. Types of drugs or medicinal compounds. First is, this is second because we have already discussed antacids, antipyretics. Antipyretics, the chemical substances which lower the temperature of body, specifically if a person is suffering from high fever. In high fever. Example, aspirin. Aspirin is basically acetyl salicylic acid. Okay. Paracetamol. Then comes analgesics, known as analgesics. They are used to relieve pain, okay, as they cause impairment in consciousness, mental confusion, okay, lack of coordination or incoordination, or paralysis. So they are used to relieve pain, okay, without causing, okay, sorry, without causing, most important, without causing. So they are used to relieve pain without causing, please remember, without causing any disturbance in the nervous system, okay, without causing impairment in consciousness, mental confusion, or incoordination or paralysis. They don't cause any of these things, okay. They are of two types: non-narcotics. Non-narcotics are non-addictive, and the second is narcotic drugs, okay. Non-narcotics or non-addictive, examples paracetamol, aspirin, okay, and paracetamol. They are non-steroidal, okay, anti-inflammatory drugs or non-narcotic drugs. These drugs, they either, especially if we talk about aspirin, they inhibit the formation of pain mediators, inhibit the synthesis of compounds known as prostaglandins, which are pain mediators, which are responsible for inflammation and pain mediators. Okay, prostaglandins. Okay. Aspirin, as they cause lower down the inflammation, they also helpful in relieving the lowering the temperature. Okay. They also help in the prevention of heart attack as they dilute the blood density because they have anti-blood clotting action. Okay. Now, there are some side effects as well of overdosage of aspirin. Is first is the peptic ulcers, okay, or intestinal perforations. That is why nowadays different types of non-narcotic analgesics are used, like ibuprofen, diclofenac, are some common analgesics. Okay. Narcotic drugs I will be starting in the next turn. Till then, bye bye. Take care. Stay safe. Stay healthy, and enjoy your new year.